G'day all. Just give us a moment to load up. Okay. All right, my name's Peter McNeill. I've been asked to give a talk today about some of the technology and processes that went into making Colossatron. I work for a company called Halfbrick, which you're all probably aware of, and mostly famous for Fruit Ninja and Jetpack Joyride. They've been around since 2001, done a lot of mobile phone games now, but as you can see, when you've done 500 million downloads, you get to have million with a capital M. We primarily target iOS and Android now. My wife brought up to me that she doesn't know what iOS is, so that's iPhone, obviously. If you see iOS in this talk, that's what I'm talking about. The main thing I wanted to talk about with this talk is that mobile phone games have gotten really, really complex now. So a lot of people, when they're starting out with making games, is you get to do the lasers and rocket ships and all of that core gameplay stuff. But when you're actually out there and in the wild now, there's a lot more expected of your games, and there's a lot of considerations that go into a title like this one we shipped at Christmas, which is Colossatron. So Colossatron is a game, a turret arranging game, where you have the giant snake robot and he runs around destroying cities, and it was mostly made by only 12 developers. They did the core gameplay stuff, which is the lasers, the rockets, and the snake running around blowing things up. But there's actually 70 people at Halfbrick, and so I'm sort of going to do a bit of a rundown on what everybody else did during that time, as well as some of the process that actually goes into the interesting bit of the game. So, I mean, I work on the engine team. I work on the cross-platform stuff that allows it to work on Android and iPhones.
You said 12 developers. How long was the project time?
It was over 10 months. Yep. And that's us. That's the 70-odd people there at Halfbrick Brisbane, and like a small portion of that actually worked on the game. Okay, so this was a photo of their room on the last day of development. Only 4 of them are actually there. The rest are spread around the room, laying down on couches and stuff, actually playing the game. The teams at Halfbrick, there's 8 teams at Halfbrick, and they all have different names. The team that made Colossatron was called the Voltrons. I work for Team America because that's the one I work for. A lot of you probably don't even really have that much idea what Colossatron is, so I will just jump in and play a quick video of the actual main gameplay loop. So you start off with a simple little snake, and it's in this news report type thing. Your job is to grab these turrets and to insert them into the snake, and then the snake will run around blowing things up. So grab a piece, put it in. It's a match 3 game, so if you get 3 of the same color, you get an upgraded version, and the snake condenses a little bit. This video was recorded at 60 frames a second. It's giving this poor little laptop hell, it seems, though, to play it back.
So do you actually control where the snake goes?
Not at first, you don't. You can get a upgrade for the snake later that allows you to give it directions to go over here or do that, but mostly it just cruises around on its own. Your job, and you'll be plenty busy doing just that, is to insert the turrets into the game, into the snake, and control which weapons you get, because all of the turrets have different abilities. It has a pretty severe effect on your effectiveness. So think of it like a mobile tower defense game, and that's sort of how it all fits together. Okay, so there's things hidden around the landscape. So there's this mega bomb that I just picked up. You can see that the yellow one has upgraded now. And you get the focus fire, which allows you to really give it some stick. And that's the mega bomb going off, and that's where I'll wrap this up. Okay, so about Colossatron. Colossatron took about 10 months to develop, which I mentioned just before. Part of the development cycle at Halfbrick is we have this pitch, prototype, and then produce cycle. So when a game team is looking to start a new project, all of the game team, and in fact everyone at Halfbrick, is free to actually come up and pitch ideas, and then if it gets past the pitch stage, we'll build a prototype of it, we'll get to the core mechanics really quickly, figure out if it's something that's worth pursuing, and if that's, from there it can have the economics of it discussed and it can go into production. So like Colossatron 1, its pitch cycle, it had a Flash prototype made, and then yeah, we originally wanted to call it Gigantor, but apparently there's already a giant robot called Gigantor, so we couldn't use that name. But this was the original pitch image, like when we sat down to do it. So you can see here, this is some sprites cut and paste from, I think they're R-Type, and you can see straight away that these were towers that you were supposed to be driving past, and they're shooting at us, and these are the little yellow segments. You can sort of see that they had the idea of what they wanted early on, and then after that, one of our talented designers went and made a Flash prototype of it. And you can see even from the initial Flash prototype that the Colossatron doesn't look that much different now in the final game than he did back then. You know, all of the core things are here. You've got the turrets, you've got the things being blown up, and he's just cruising around on his own, and you're upgrading him. And yeah, so that's how the process started. But once we're actually in development, what tools do you actually use to make a game like this? I mean, I know a lot of you will be familiar with things like Unity, but that wasn't around when we did Fruit Ninja, and it wasn't around until just very recently, actually. So we've got a fairly extensive set of our own tools for doing all the cross-platform works. But the main tools are Visual Studio, Adobe Photoshop, 3D Studio Max, Xcode on a Mac, and Flash, which we use for the prototype. And I think it's really important to note that there are free or student editions of all of those things, and it's no different than what you can just go get now off like Microsoft's homepage or whatever. It's not hard to get a hold of this stuff. We have our own internal tools too, which is Mortar, which is roughly equivalent of an engine for us, which it does our cross-platform work. So if back about 3 years ago, there was a bit of a mobile phone war going on, where there was Nokia was still big players, there were BlackBerry, there was Samsung had a different operating system than they do now. We needed a cross-platform solution for Fruit Ninja, and we needed to, at one point we had 60 different builds of Fruit Ninja for all these different devices out there. So that's the origin of Mortar, and what it really does is provides us with a minimum target to platform with textures and sounds and all of that sort of stuff that we can go and build our games on top of for all of these different devices. But nowadays it's really just iPhone and Android. We have some other things too, like we have Brick UI, which is roughly the equivalent of things like Scaleform, but it's our own custom implementation. BrickNet, which is our internet services for cloud saving, advertising, all of that good stuff. PropEd, which is gameplay property editing. We have a build tool which manages artists building things in like TGAs and WAV files and outputs compressed OGG files and compressed PVR textures and stuff like that. And Babblebrick, which is our language localization tool. You may notice that there's a bit of a theme where we tend to use the word brick a lot, or brick-themed things like Mortar and other names. We're engineers, please don't think less of us. Okay, so a little bit about Mortar. I've already gone into it a bit. It's mostly written in C++. There's Small bits of Java on it for where it has to interface with Android. There's small bits of Objective-C where it has to interface for iOS, but mostly it's a C++ engine. We still use it for everything. So the current builds of Fruit Ninja and Jetpack Joyride are still using the same engine that Colossatron shipped on. Radically different games, radically different system demands. And the reason that is because the actual mortar isn't the engine. Mortar is just the underlaying bit, and the game teams build sort of a mini engine on top of that specifically for their games. And as I was saying before, like once upon a time, the mobile phone ecosystem was a lot deeper than it is now, and mostly the depth comes from performance, where you have your entry-level Android phones now, and then you have your top-end devices that are coming out this year, and the factor of performance there is nearly 50 times. So you need to be able to have an optimized engine, so if you're building for a mid-range phone, it's still going to run acceptably on a low-end phone, and not look like rubbish on the top-end phones as well. Performance is such a big part of that. Just skipping forward though, mostly though Colossatron itself, even though we have access to 3D models and all of that good jazz and shaders, Colossatron is basically a love letter to all those 80s arcade games like Raiden and 1942. So this game is built almost entirely out of sprites. We often have 2,000 plus sprites during gameplay, which wasn't our original intention. When we first gave it to the game teams, they had about 200 objects running around, and it was pretty fun. And then the designers kept ramping up the amount of stuff that was coming in and attacking the snake. And so we went back and revised the engine, and we got the number of things that we could draw up, and then they went and used it. And so I've clocked this game doing 4,000 sprites at 60 frames a second at times, which is pretty damn crazy. Yeah, one of the other requirements is our games have to run at 60 frames a second, and the resolution that they have to run at is pretty mind-blowing on the top-end tablets. We hear about Xbox One and PS4 complaining about having to run at 60 frames a second at 1080p. Yeah, that's cute. Yeah, the main reason we're able to get such performance out of this is because we do a lot of sprite sheeting and a lot of batch optimization. Mobile phones have really, really fast GPUs in them now, but they have really, really terrible drivers. So the less time you spend talking to the driver, the better the performance you get. One of the numbers I really like to tout around is we actually finally got around to clocking how long we were spending in the drivers on the iPhone 4, which is a fairly old phone now, about 3 years old, and it was 0.3 milliseconds per draw triangles call. Even if just drawing a single triangle, it was 0.3 milliseconds. When you've only got 16 milliseconds to draw your whole frame, you're not getting many draw tries calls out. So the much stuff that you can cram in there, the better. Everything we've done to reduce the number of draw triangles counts, even no matter how wacky it's been, like if we've basically emulated the entire driver stack and done it ourselves, has resulted in speed ups. They are really that bad. So have some patience with the Unity guys with getting their 2D system up, and that's why they have to do that, is because it's not an intuitive thing to actually have to try and build. Yeah, in terms of the actual assets and stuff that we had 400 meg of sprite data for Colossatron when it's all just sitting uncompressed in 32-bit RGBA, and we had to get it under 70 meg to ship with to fit in the sounds and all of that stuff. So mostly that was texture compression and lowering bitrate and stuff like that. Yeah, so you can see here with this one, a lot of the game with sprites is just layering stuff together. So you have the shadow, then the main body, then the armor piece and the turret, and you layer them together and you get one of the segments.
I'm asking you about the compression. So you say 400 megabytes of sprite data decompressed.
Yep.
What's the method of compression?
The main method of compression for us, because we had a really nice flat art style, was lowering the bit depth for us. So dropping to 4 bits per channel was the main one. And then for where we could get away with it, we used PVR or PVR for iPhone. Yeah, so here are some of the sprite sheets that we put together. We let the artists work on just individual little images of arbitrary size, and then we made lists and we packed that down into these sprite sheets using a tool, and we tried to organize it because of the batch considerations, so that like similar things would be on similar sheets. So you can see all of some of the enemies here, like all of the little dudes that will be running around when there's a army of little men running at you. They're all coming off the same sprite sheet, so we can eventually fold them all into the same draw call. Same sort of thing here with this one, whereas when there's hundreds of bombers flying overhead, they're all coming off the same sprite sheet. Explosions, just because I thought I'd break up the talk a little bit. Here's the explosion sprite sheet that we have. You can see it's just a sequence of frames that we've packed in, and then they still just refer to the original file name when they're authoring the game, and then it pulls it out of the sprite sheet as they need it. The backgrounds behind it are again just big sprites. You can see that these are 1024 by 1024 textures that have a bit of the debris and stuff painted into them, and then we plonk building sprites over the top of them to actually put together the landscape for the game. You can see the sockets here. They had to place the buildings, the trees, the cars, and all that sort of thing. It was actually really interesting watching the artists go through and having to place hundreds of parked cars all over the landscape. And in almost every single time where they had to put cars in, someone parks badly. And so there's a little bit of a running joke that we think Colossatrons come to Earth mostly to clean up bad parking jobs. Okay, the other part of the visuals is the user interface, because I mentioned we have our own sort of scale form type thing, which allows us to build the user interfaces and the text and stuff for our games. This is what Colossatrons looks like with the game turned off and just the user interface running. You can see it's just some numbers popping up and some numbers ticking up on the side. Really not that much going on, but it does contribute a lot to how the game's put together. Like you can see, if I flick it on and off now, nothing on, off. You get that sort of thing. This was a minor use of the user interface in the game. The main thing that we used it for is once you get outside of here, you have this sort of thing. Like all of these menu screens are put together with the interface tool and all of the animations for it. So if anyone's actually played the game, these weapons coming up are actually spoilers. They're not out and available to the public yet. They'll be out in a couple of weeks. So this little sucker is not out yet, nor is this one. So you can see all of the text, all of these menus that you swipe through and all of the control for them are all handled by our in-house user interface tool. We used to code our user interfaces by hand, which I don't recommend for anybody. If you can find some sort of middleware to handle your user interfaces, find it and get good at it, because games are more and more about these sort of screens now when you have in-app purchases, you have leaderboards, you have stuff like that. Doing that, rolling that by hand will just eat inordinate amounts of your time. So the more you can palm off to a designer where they can just, what you see is what you get, the better. That's not my mouse. There it is. Yeah, okay, so a bit more about our user interface tool. The main thing about it is that it's live editing in the game. So we can have our game window running, and we pull up the user interface tool behind it, and we can grab stuff and start chucking it around and see what it looks like at different resolutions and different aspect ratios, because like some devices are 16 by 9, some are still 4 by 3. We had a BlackBerry come through recently that actually had a perfectly square screen, which I have to say I haven't seen one of those in years. And it also, another big part of the job is because we have so much text in our games now, we have 14 languages that we need to localize to. And the text changes width and dimension. Like when you say hello in English, you switch to German and it's like 26 characters for the same word. So you need to be able to fit all of that in. It's got a lot of optimizations, the same sort of things that we have for the sprites, which is fill rate and batching, you know, the same sort of thing where we use a lot of sprite sheets to put together the interfaces. And the other thing is that the game teams keep subverting it to build gameplay elements, which is something surprising. So I showed you just before that all those numbers were popping up. We had the guy who's responsible for building the user interface. He got dragged in front of the game teams, and they were complaining that those numbers weren't running particularly fast. And he was like, huh? What is it? Because they nicked those numbers. They're using the user interface tool to display the scores popping up on everything, and he had no idea what it was, so had to go through and optimize that for them. Yeah, so I mentioned before about Halfbrick and about we have to go to 14 languages. This is a partial overview of what that looks like for us. When we have text in the game, we use these, I don't know if you can read that from back there, it's kind of might need to zoom in a bit, but we use placeholder bits of text like _stats, and then that unrolls out into the English or the French or the Italian versions of all of those things. And so here's a picture of the editor. You can see it's got all your properties for all your components, an animation track editor down the bottom here, performance stuff, and a list of all of the components that go into this screen. This screen here has currently 1,025 individual components that are being placed by some designer to put this together. Bounding boxes for all of it. Turned a few things off so you can actually see what's going on here. And I'll just run through a quick video of what it looks like when you edit this sort of thing. So you can just, it's literally what you see is what you get. The game's running at the moment. And you can just grab it, rotate stuff, grab that, and it'll start editing the text there on in a second. You can see the pre-localized string, which is menu_attack, and then I can just type over that and put whatever I want in there. And as I mentioned before, if the string is too big for the actual bounds of it because of translations or whatever, it will automatically shrink the point size of the text or spread it over 2 lines if there's enough room to do that.
Can you do it in real time, or do you have to pre-calculate some of that to save?
No, we do it all in real time. One of the big things about our text system is we had a game called Fruit Ninja about 3 years ago that had about 60 builds, which I mentioned, and the reason that is because it had 14 languages. So if we did an update to the game, we had to do a Chinese update of the game, we had to do a French update of the game, we had to do for all of the different regions, and that was because the game had to ship in under 20 megs. And when we unrolled the character sheets, like the font sheets for Chinese, there's 6,000 characters in that, and that's roughly 70 meg worth of text data on its own. So what we did is we went nuclear on it, and we have a system that actually takes, we just ship with the TrueType font as the actual game asset, and we rasterize it into texture atlases on the fly to produce all of our text effects. So I was mostly responsible for that, so this gets its own slide. I'm being a little bit self-indulgent. Yeah, so you can see we can do all the stuff like the drop shadow, the strokes, the gradients, the bevels, font changes, and the point sizes, and they all come out pixel perfect. Like, so if you get it on the latest and greatest iPad 4 and it's got like 2,000 pixels wide or whatever, we will generate the glyphs at 250 DPI versus on an iPhone 4 where it's 75 DPI. We actually build them exactly for it. So we pretty much have the nicest text anywhere, and I'm really proud of it. With the localizations, you can see here. So this bit of text here is normally only 2 lines in English, but you can see that it's downsized a little bit and wrapped it onto 3 lines for the French version, and change your degadget, which you can probably figure out what that means. For Russian, we actually use a different text type altogether, which I think looks pretty amazing. I really like this Russian font. You can see that it's, again, had to fit things onto different lines, and the Russian is a little more blocky, but it still all works.
Do you support right to left layout as well?
Yes, we do. Japanese, seeing they were using the user interface tool to build that Channel 6 news that scrolls behind Rick's head here, that gets translated directly into Japanese. That was no effort for us, it just swapped it over. And as I was mentioning, the right to left layout, so we have the Arabic here. that was quite a lot of work because nobody in the office actually speaks Arabic, so we had to keep sending away stuff to translators to say, did we get it right this time? Because Arabic is actually a 3-stage transform between what you actually write down and what you actually end up on screen. Like you have to do the BiDi right to left transform, you have to do character substitution transform where like 5 characters gets transformed into 2 characters with joins between them, and there's a bunch of stuff like that to considerations. And if you don't read the language, it was quite difficult to work out. And that's it for the user interface for the moment. The next bit that we're moving on to is sound. Sound was handled almost entirely by one guy, a very talented sound engineer who sits right across from my desk. My wife got to meet him recently at a staff Christmas party and goes, "Oh, hi, you're the Splash guy." And he didn't know what she was talking about, and I didn't either. And apparently I'd been complaining that he'd been splashing around in a bucket of water for 3 days, recording all the sound effects for Fish Out of Water, and had gone home and complained about it, and that's what she'd taken away from it. So for the sound, we have 500 sound effects for the game, and most of them are variations on things. So instead of just a single explosion, there's like 6 different explosions for buildings blowing up, and they're all just slight rearrangements of the same basic theme, like an explosion, some rubble falling down, some glass tinkling, that sort of thing. I have 6 great samples here for you, but this laptop doesn't actually have sound hooked up to it, so
There's a little plug there. We might be able to plug it in for speakers.
I didn't even consider that there was actually sound. Well, we can come back to this, but you guys have heard explosions before, so I'm sure it's not.
That's some gas.
Yes, I have successfully destroyed the...
We can try this.
All right, let's see what happens when you do that. All right.
It's muted, I think.
That sounds better. Sounds like something's going to happen.
It's muted down the bottom of the screen.
Is it? Oh yeah, it is too. Oh, that's going to ruin it.
It's going to be really loud now, probably.
That's right.
Oh, let's go back one. Yeah.
The flashboard, the flashback as well.
Mm-hmm.
I suspected.
Yeah.
It's working.
Yeah. Okay, so you guys aren't going to hear the explosions today, but basically it was all variations on the same thing. So.
Is he also the sound guy?
This gentleman here is General Mustache, who does the all soldiers attack, sort of yelling and growling. He was in a pirate metal band, which pretty much sums up why he had the right voice for this. Yeah. He's a pretty good programmer too. He actually works on all our BrickNet stuff now. We didn't actually hire any professional voice talent for the game. These are all just friends, family, and employees that we managed to rope in and do it. For our next game, we actually did get some professional voice talent in, and it sounds so much better. Don't use your friends and family.
Did you have voice lines for different languages as well, or?
We didn't, and we've copped a lot of flack for that, so there may be a French version of General Mustache coming along shortly. Mostly the French seem to be really upset about having to hear bad American accents. I don't know what that's all about, but yeah. The next part is our BrickNet service platform, because I mentioned before that a lot of what goes into these games is stuff that you never think about, and one of the features of Colossatron is that it has cloud saving, so if you switch between devices, your progress is kept. Even if you switch between an iOS and an Android device, the progress is kept, which is pretty unique out there. And we also have leaderboards and in-app purchases. We were using we were going between third-party provider and third-party provider for this sort of things like Flurry and Game Center and stuff like that. And as our games got bigger and bigger, it became more and more apparent that they really didn't want to have to deal with us anymore, because we would just murder their servers at Christmas time and stuff like that. So we've rolled our own. It's hosted on the Amazon Cloud AWS, which is they turn servers on and off to meet demand. So if you can see this blue line here, this is a single day's worth of traffic where it goes up and then comes back down. So you can see that we're turning servers on and off throughout the day here to save a bit of money and hopefully the environment a little bit, but that's really a secondary consideration. Yeah, so it serves well over a terabyte a day, and only about 10% of that is Colossatron. Most of that's still taken up by Fruit Ninja and Jetpack Joyride.
Developers are working on BrickNet?
BrickNet is currently 12 developers, so equal to the same size as the team that actually made the game itself. But they have to support 5 other games that are in development, so it's really not just the Colossatron guys. In fact, Colossatron barely uses the BrickNet service. If you have a watch of this video, I'll show it exactly what it was used for. Oh, hey, we did have some 3D model rendering too. That's the other thing. That just for this little world map, they stuck that in at the last minute. And here it is. Dozens of servers and 12 developers, and we have a very, yeah, never mind, moving on. The other people, one of the other big systems that we have is our analytics system, which you don't ever hear much about, but we keep track of what users actually do when they play the game, and we anonymize it and we collect it and store it. When you have lots and lots and lots of people using your service, you really want to know what sort of experience they're getting from it. You know, you can get the reviews of people who haven't even played it yet, or you can actually pull up the numbers of where people are getting stuck or where people are actually putting the game down, how many people are playing on Android, what sort of devices people are using. And so we have our own internal software for tracking all of that stuff. And that, again, is also best friends of these guys, which is our marketing team. We only have a small marketing team, only 9 people, which if you've been around the industry for a while, you know that that's actually a very small marketing team. They produce all our promotional trailers, our websites, our web campaigns, all of that sort of thing. They're actually a bunch of really good guys, because once you start dealing with Apple and Google directly and become best buddies with them, they chew up a lot of time. And they handle that for us now. So they kit the development team that's actually building the game and the lasers and the explosions, so they don't have to deal with Apple so much. And the last and probably the most important external team to them, besides the engine team, were the QA guys. We only have 4 QA guys at Halfbrick, which when you hear about there being hundreds and hundreds of QA people at places like EA, it makes you wonder exactly how that sort of thing happens, because we only really had one guy do all of the QA for all of Colossatron, and it shipped mostly bug-free. And I think the difference, of course, is that they aren't bug testers at Halfbrick. Our quality assurance guys are gatekeepers on the product, they're stakeholders on the product, and if the QA guys say, nah, it doesn't go out, you know, it goes back in and they fix the bugs. So if QA are reporting critical bugs, we don't ship. And they get to see things that nobody else ever gets to see. And I've collected a few screenshots of those here for you today. So this was one of the ones that happened early on when we started having the space transition screen back into the main game. And so we're playing along casually, and another Colossatron turned up. And this was astonishing for 2 reasons. 1, we have no idea how it happened, and 2, the code didn't crash. It was actually quite playable, and he cruised around, and yeah. Yeah, we had a different snake for the news segments. Like when there's news segments that flash before the thing, he wasn't cleaned up, and so he was still in the entity pool when the game turned up. Colossatron did. This was when the Russian translations first went in, and we hadn't sized any of the text bounding boxes. I believe the game is yelling at us is probably the closest translation for what's happening here. This one, we get device-specific bugs all the time, where the game works perfectly well on all of the devices, and then you throw it on an iPad 1 and it looks like this. Many people are blaming Halfbrick, was what was left on the screen here at this time, and I don't know who else you would blame, so I think that's about right. And the final one is this, where also phone was stopped, and we had to take a photo of the device because we couldn't actually get a screenshot of it. It's just... the QA guys have to test on literally hundreds of different devices because we go out on Android, and Android's such a deep ecosystem, and we go out on iOS, and that's like 15 phones deep now too if you count all the iPads and stuff. This is a small collection of what's not currently checked out of their device stash. See all these gaps? These are normally piles of phones as well. It's just they're all out on everybody's desks on that day, and I wasn't going to bring them all back in for just a photo. But yeah, it's pretty crazy. The electrician's nightmare when you see how many little power chargers and stuff are plugged into them there. And that pretty much wraps up my talk. It's really just a bunch of conclusion points now, which is that I wanted to iterate again that prototyping is invaluable when you guys are doing your games. Your ideas are cool, but if you just decide I only have one game that I'm ever going to go out and make and I'm going to drive it into the dirt to get it done, you're probably doing the wrong thing. Like we went through 12 different ideas before we settled on Colossatron, and we do that for all our games, and it's way more successful to go through and toss ideas out and then come back to them later than to just like be dog-headed about it, because even though you may be throwing ideas out, you will still find some way to use it later. These things aren't wastes of time. You will find ways to use it later on, so there's no point in being precious about them early on. The other thing is that a lot of the back, because there's so many systems going into all of this stuff now, a lot of the decisions are the same trade-offs that high-end titles are making, especially regarding resolution, storage, and speed, which I've gone into a little bit. Because like the lasers and explosions part, that's only a small part of what's actually going to go into a game if you're hitting all of the other things like translations, analytics, achievements, leaderboards, cloud saving, all of that sort of stuff. We had entire other teams dedicated to those things to get them done, and they're complex. And you don't need to do them if you're just starting out, thankfully. It's something that's sort of crept up on us because we have such a big audience now. If you're just starting out in the marketplace, you really don't need to worry about it, which is why I thought it might have been interesting to show you a little bit of what goes on with that today. And the other thing, of course, is that none of the tools we're using are magic. Like it's all the same tools that's available to everybody else. And you guys have even better tools in terms of things like Unity, which takes out a lot of the considerations that we had to implement ourselves, like the cross-platform support and all of that sort of thing. You guys have access to that now, so there is that. That pretty much wraps me up. Did we want to do some questions and answers or dig deeper into any of this sort of stuff?
Yeah, I just have a quick question. I've always wondered about this, like, as you say, like when it's ported to different like iPhones and Samsung and all that, like when the screen ratio changes, does much consideration go into rebalancing the games to allow for that, or is it pretty much the game just runs and...
None. Colossatron wasn't a problem with that, and neither was Fruit Ninja, because in Fruit Ninja we don't use the top part of the screen anyway, so you just use less of the screen top real estate for that because the fruit comes up and then comes back down. But for Jetpack Joyride, Barry actually moves off the left-hand side of the game wall more and more as the aspect ratio gets more and more stretched out. So you still have the same amount of screen to the right of Barry no matter what aspect ratio device you're on.
That's a size. And what about sizes between, like, say, iPads and like phones? I guess you just account for that when you're designing for both, I guess. So.
Yes, it's tricky. Yeah, we have to account for that. User interfaces are mainly the big problem when you switch between the aspect ratios, which is why we came up with our user interface software and put so much time into having some really good ones, because 4x3, you can't fit three buttons across the bottom of a screen, but in 16:9 you can. So we actually have a thing we call SKU support, which is for when you switch aspect ratios. We actually allow the designers to go in and, okay, what's it look like on an iPad? It switches the aspect ratio around, and they go, ugh, and they can grab a button and nudge it around, and then it'll keep just that little change just for that setting, for when it gets pulled up on that device.
Yeah, thanks. I was also wondering the best way to approach
Mostly docking and dockable layouts. Like, I don't know if you've ever done any WinForms development where you can say, anchor this to the right-hand side of the screen, anchor this to the left-hand side of the screen. This fills this space. All of that stuff works perfectly on device. That's really the best approach we've found for that sort of thing.
I was just curious on how early and how often do you do actually testing outside the company, like with players?
We use a version of Test Flight. I don't know if people are familiar with it, which is software that allows us to deploy our builds onto a website and allows people to go through and pull down builds and play early versions of them. We often do friends and family weekends when a build is getting close to finished, but mostly we don't honestly do it that much until the end of development when we're getting ready to do stuff.
I'm really curious because for a while it's kind of the opposite. We do that intensely, like at every step they do a lot of testing for players and then watch them and analyze their reactions and stuff like that. So
yeah, they do, but they've also started using more of a games as a service model too, where they're developing the games as the people are playing it, which is cool if you can pave a road while people are driving on it, but not everyone's set up to do that.
Do you focus test any games before you even?
Absolutely, we do focus testing.
That's before you even do it on the.
Well, like with Colossatron, that Flash prototype, that went out to the whole company. We do a lot of prototyping at Halfbrick. People have probably heard of the legendary Halfbrick Fridays, where basically we shut the company down for like a week or 2 days out of a week for a month, and we get some time and we break up into different teams and we shuffle around, and whatever you want to pitch and prototype, you've got some time to actually go and make it.
Do you test it to the public though? Or
No, we don't, but we may be doing something like that in the future, like with Double Fine released a bunch of their prototypes, and we've got way cooler prototypes than they have, so we may end up doing something like that in the future. Like that Flash prototype for Colossatron went out to the whole company, everyone played the heck out of it, and that's sort of how that one got greenlit. We were sitting on it for a while before we decided to go ahead with production of it.
What text library did you use to rasterize the fonts?
FreeType.
I suspect. Okay.
Yep.
Is the code that you have produced available?
We didn't actually make any changes to it, so
Okay. So you're just using the library for basic?
we're literally using the library.
Straightforward to it.
Yep. We submitted a few bug fixes to that, to them to make them work properly on a couple of the more obscure devices like Nokia's.
What about affordability of that library?
Well, it's just standard C code. The main problem was there's a few devices out there that don't support set jump, and so we had to patch their code base to fix that. And I'm also surprised with myself that I remember that, because that was 3 years ago.
Just regarding, you were talking about the driver costs, which most Android developers working up against. That sounds really high. Is that because most of your vertex buffers are dynamic? Or were you finding the same kind of cost for static vertex buffers?
It makes no difference at all. A lot of the things that people think are actually better. I could talk about this for hours. This is my expertise right here. A lot of the things that people think are best practices for working on these devices is bunk. Because when you actually get down and test it, a lot of the things that they tell you to do, like pad your vertex buffers out to certain sizes and certain things like that, it's rubbish. It makes no difference to your performance whatsoever. There's also no difference between dynamic and streaming. And so if you can use dynamic arrangement of vertex data to get better batch performance, do it. By God, do it. Because
Do a whole talk on that, and I'd be here in a heartbeat.
yeah, I'll do that next time then. I didn't know what level today was being aimed at, so I sort of did an overview of all of the processes, but that's what I do for a living, so yeah.
Actually, just another one along those lines. I noticed that you described chips as well, like alpha's a big issue on mobile chips as well. And I was sort of looking at them going, oh, look, there's lots of empty space there. Were they actually, but the edges I noticed were fairly regular. Were they actually poly cutouts, or did you just draw them to big quads in there?
No, we just use standard alpha blending. We actually use pre-multiplied alpha, but yeah, it's again one of those things that's there's a lot of misinformation out there in the industry where it's like, fill rate's a big issue, and it's like, it is, but it's not a bigger issue as you're thinking it is. Like doing triangle cutouts around the models and stuff like that. It's like, unless you can do that and also keep your batch size small, like because you're using different models and all of that, it's not worth doing. The main reason we have so much alpha edges around those guys is because when you get your map chains down and you minimize them, we needed the padding around the outside edges to make sure that we weren't getting bleed over on the sprite sheets for the edges of the models.
Actually, if I could just shoot along these lines, probably one of the big things for the small guys, so to speak, is that we only have a couple of devices to test on, and we've seen from your photographs how many you guys. On those performance issues, how much variation do you find?
Okay, so really it's a matter of finding your lowest end device that you really want to support, which for us is like the iPhone 4 and the iPod Touch 4, and getting those devices and testing on them or even developing on the lowest device that you're comfortable with and targeting for that. Everything goes up from there, and sometimes it goes up exponentially, but it never goes down from those.
So do you scale your detail when you get them?
We do to an extent, but only when we absolutely have no other choice in the matter. Like, for example, Fish Out of Water on the iPhone 4, we could not get that game running at 60 frames a second on an iPhone 4, and so we don't quite render at native resolution on that. We render at 3/4 resolution. But that's the last time in years that we've had to actually adjust the detail of our games. Everything else is just native res. Oh, and the font system, of course. The font system dials up the DPI to match the screen.
Are you still supporting the iPad 1?
Pardon?
Are you still supporting the
Yes.
iPad 1?
Yes, we are. That's almost a...
iPhone 4 is slower than the iPad 1?
Just a touch. The iPad 1 is clocked slightly faster than the iPhone 4 by about 200 megahertz. So it is actually a slightly better device. In fact, the lowest end device isn't the iPhone 4, it's actually the iPhone 3GS, which is, you might think, why are we supporting that old phone? But it has almost the same chip in it as the iPhone 4, but renders at half the resolution, so it's actually a beast comparatively to the... we actually really like that little thing. It's like, look at this tiny little screen and it screams. Sorry? Yeah, it's 256 meg. It's not as bad as some of the devices. Yes.
So I just got a question on that decision because I still do have an old iPhone, and the number of things I now can't play on it really pisses me off. I'm about that rate, but it just seems to me that seems to be the MO for most games is we won't support anything older than 2 years.
Oh well, sometimes you have to take the developer's word for it. I'm not going to name names this talk, but maybe over a coffee later. We had a device right before Colossatron shipped that we were not allowed to exclude from the list of supported devices. Like a certain big name company said, no, you're not allowed to exclude this device. Like there was no option to exclude it. And so we ended up having to exclude a whole bunch of devices just to skip that one device, because that device only allowed us to have 75 meg of RAM. Which is... Sometimes there are external pressures that cause this sort of thing to happen. We would obviously like to support as many devices as we can. Apple is sort of forcing a hand with a little bit too with the upgrade to iOS 7. The developer toolkits don't let you target anything below iOS 6 anymore. So people with iOS 5 and a device that can't upgrade to iOS 6 or iOS 7, we literally cannot make a build for you anymore. There is no way for us to update that version of the game anymore. So it's not always on the... it's not just mercenary or we don't want to test it. We literally cannot. Pardon? Oh, it's pretty arbitrary at times, yeah. Anything else today? Oh, okay.
What's the process between the game development team and the engine team like? Because you said they build on top. Do you have issues where they ask they need more speed? Like, I guess all the time. How do you deal with that?
Yes. Often what happens at Halfbrick specifically is I feel like a bit of a doctor at a learning hospital sometimes, in that I go around and I do morning rounds. And so I actually will go and embed in the game team, get up from my desk, walk over and stand behind people while they're working on it and identify problems and identify speed issues and stuff like that. And often I'll have a game kick back to me and they'll say, can you profile us and figure out what we've done stupidly? And we're getting better and better about that sort of thing. But mostly it's about correctly kicking off a task before they start on it now. So if they come up to us and they say, we're going to start doing the bullets in Colossatron now, can you quickly run over what would be the best practices for that? And I'll sit down with them and we'll work out what we've got to do. And it really has boiled down to use sprite sheets. I mean, that's really, it's the same thing over and over again. Draw less, use sprite sheets. Don't do silly things in the game code like not have broad phase in your collision detection, that sort of thing.
So they kind of seek out you for the technical advice on how to implement their scripting ideas as opposed to like straight themselves.
Well, yeah, they produce a lot of technology too. The automatic texture atlas builder for Colossatron was written by the Colossatron team. It wasn't written by the engine team. The engine teams are supporting like 5 other game development teams at the same time, so we embed where we can to help them out and help them kick off stuff, but we're not there through a lot of the decisions they make too.
What's your development tooling look like? Do you have continuous integration, code views, source control, obviously?
Absolutely, we have all of that sort of stuff, and I thought people's eyes would roll up in their heads if I mentioned it. We use Jenkins for our continuous integration, and we use Perforce for our source control.
Yes, I guess the continuous integrations usually implies build automation.
Yeah, we absolutely.
Red flashing light.
Not so much, but we do get emails around when things break. For certain parts of the engine, we have a 2-step check-in process where the code has to be reviewed by another member of staff before it's allowed to check in, like the cross-platform software that's used by everybody. That's all coming out of the same branch. And so if you make a change to that, somebody else has to read it and check it in, and there's really strict standards on it. What the game teams do themselves, though, that's really up to them. We don't police that so much. But after a check-in is done on Perforce, that kicks off a Jenkins build, and you get the Android build, you get the PC release build for the developers to, the designers to use, and you get the Android build, and you get emails back about any problems with that sort of thing.
How do you manage release of engines with game teams? Is there branches or something like that?
We did that for a while, where we were having branches, but because it's more of a framework than an engine, there's often things added to it that everybody would benefit from, and so everybody being on different branches turned out to be a bit of a nightmare. So typically now we only branch right at the very end of a project, right in the last 4 weeks when they're in code lockdown. They'll make a branch there temporarily and then go back onto the main branch. Normally we all just work out of the same branch, but it's not Wild West in there. As I mentioned, it's all carefully reviewed before any changes to that are made.
Do you ever get to a situation where you added something for a particular game and for some reason that breaks another game because it's shared code somewhere?
That was something that was an issue when we first started doing it, but it's less of an issue now. We actually have a little counter by joke in the engine team, like days since we broke something, and it's like triple digits at the moment. So it's not that big an issue.
Yeah.
Have you spent time assessing like QT just to see how that does things on target platforms?
I'm sorry, I'm having real trouble hearing you.
Sorry, have you spent any time assessing something like QT, which is just it's a common software framework, like it's just started targeting iOS and Android? I'm just wondering, it's probably a little bit different.
Yeah, no, I've actually spent a bit of time in Qt because we were doing I can't remember the name of the operating system that Qt was integrating with for Nokia before they killed it dead. No, they had MeeGo. MeeGo, yeah. We did a MeeGo port of Fruit Ninja, and I did that personally, so I have spent a bit of time with Qt. It seemed a little schizophrenic to me, that software platform. Like, it wasn't really sure what it wanted to be. Like, did it want to be... Yeah, back then it was like, were they being a rapid game prototyping framework, or was it a windowing toolkit? And it was sort of not sure which way they were going to go on that back when I saw it. And I'm glad to hear that they've picked a direction and gone with it.
Well, they're still kind of going into starting to narrow in on one.
Yeah, well, there's not actually that many good windowing toolkits out there, so I mean, more power to them. I hope it gets picked up. Maybe they could integrate into Unity or something like that and get some.
So the UI system is completely custom, your own invention.
Yes, we have a dedicated tools guy who does nothing but work on that, and I spent a little bit more time on that than I did on other things, but that's mostly because it really is the only piece of middleware in.
And the closest like commercial equivalent scale for it.
Yes, and we kicked the crap out of that, so I'm quite happy about that. We mostly have a lot of considerations for fill rate usage and stuff like that. So when you start having large overlays all over your game screen, you've really got to pay attention to overdraw and things like that. And so we do tricks like when you have a screen full of text, we put down a render to texture and then raster into that and then just draw the quad. So we're not multiple blending all of those pixels for that sort of thing. So, and a lot of that is seamless to the designers too. They just put together things and layer it up how they want, and then we do the magic on the back end of it. Any more questions? No, great. Thanks for your time, guys. Sorry if I wandered around a little bit with this. And that's it.
Between all of the different disparate platforms.
Is once you start dealing with Apple and Google directly,